Hello everyone. In today's session, we will try to take more questions on sets. Though topic is not all that difficult, but at times language of the question may perturb you. So just to get feel of the topic, we will take more examples. So my first question is that two finite sets have m and n elements. The total number of subsets of the first set is 48 more than the total number of subsets of the second. Then what are the values of m and n? Now when you read this question has not given any names. But then just to start with, I take first set as say A and the second set as B. Question says that number of subsets of first set means number of subsets of set A is 48 more than number of subsets of set B. Now what is the number of subsets of set A? If A has m elements, we have done in our previous sessions, it would be 2 raised to m. And the total number of subsets of set B would be 2 raised to n. Question says the difference between them is 48. So 2 raised to m minus 2 raised to n is 48. Now m and n are to be obtained. And the only information is given in one statement. That is 2 raised to m minus 2 raised to n equal to 48. Normally, when we have two unknowns, we are given two equations. I mean, this is how our childhood algebra tells us. But then no other information is also given. We are still expected to solve. That means some hint hidden in the problem only. We will have to rearrange the terms. We will have to do some trick so that I should be in position to evaluate what could be m or what could be n. Some of you may think that we will keep giving values to m and n, different values, and by hit and trial method, I can get m and n. No doubt you can get, but after few attempts you will get. So obviously that will need some time. So instead of wasting time like that, I would suggest you that rewrite that 2 raised to m minus 2 raised to n. For that, what I do, I take 2 raised to n common, then 2 raised to m minus n minus 1 equal to that 48 we write as 2 raised to 4 into 3. So the hint is that if I equate n to 4, then the 2 raised to m minus n minus 1 part needs to be equated to 3. That 3 also I can write as 4 minus 1. So that m minus n part can be written as 2 because 2 raised to m minus n I am taking as 4. So n equal to 4 is known to me. I get m minus n as 2. Substitute n, that will lead to m equal to 6. And m equal to 6, n equal to 4 is the right answer. So we have values for m and n as m equal to 6 and n equal to 4, and that tells us that C is the correct option. So this particular question I tried to take because it had information only in one equation form and there were two unknowns. So the question came. Now let us move to the second one. Second one says that universal set I am taking as 1, 2, 3, 4 up to 9. Set A is described as x belongs to n, means natural numbers, and condition is that x square should be between 30 and 70. So we will have to write for A separately the elements. Now B is also not given in the listing form. It says that set B is x is a prime number less than 10. So both the sets A and B at this moment are given not in the listing form. We will have to derive them. Then which of the following is false? And then follows A union B, A intersection B, etc. So to answer those A intersection B or A union B, we will have to work on separately first A and B. So we start like this, that A should be, I have written there 6, 7, 8. Why do I say so? Reason is that if x was 5, then x square would have been 25. So it is less than 30. So x equal to 5 does not come in set A. 6, x square 36. So x equal to 6 gets its place in set A. Same is with 7 and same is with 8. 8 square is 64, which is less than 70. So number 8 also gets place in set A. When you move to 9, its square will become 81. So that will not remain in the set. So set A has only 3 elements, 6, 7, 8. I hope everyone understands. Now set B is described as that it will have those prime numbers which are less than 10. So which all those numbers are? 2, 3, 5, 7. So now we have described A and B. Now try to answer those A intersection B or A union B or A minus B. What would be A union B? A union B would be 2, 3, 5, 6, 7, 8. And here A union B matches. But question is regarding which of the following is false. That we have to find. So A union B is correct. So statement A is correct. So that is not our answer. A intersection B and A minus B. You can write down on your own. A intersection B means the common ones. And the common ones means only element 7. That is singleton set 7. And A minus B means what? The elements which are in A, not in B, are 6 and 8. 7 is present in both. So that we remove. So we have A minus B as 6, 8. And A intersection B as singleton set. So the correct option should be the one what we want is option B, because it says A intersection B is 7, 8 and what we have found is 6, 8. So in some questions, set A and set B are not given to you. You have to derive them by given information. Then I move to next. And the next question is in very different form. Set capital X is defined as set of X, Y, where the second number Y is described as 1 by 4 raised to X. Now this is something different. We will have to again write set X separately. Set Y is described as that we will be writing X, Y type of pairs. But which type of pairs? The ones which satisfy Y equal to X. And then again 4 options are regarding X equal to Y or X intersection Y, etc. Which of them is correct? That we have to answer. Now, I write first set X. I try. I look at X and I get that it is of the form that Y is given of the form A raised to X, where A is 1 by 4. So that is less than 1. Means if I am taking it as A raised to X, A less than 1, if that condition is to be used, those who are good at drawing graphs, they will be able to understand that line Y equal to X, and if I draw a graph of Y equal to A raised to X, when A is less than 1, these two graphs for the given information will meet only at one point, and that should give us the corresponding value of X. And that happens only at X equal to half. So if I substitute back X equal to half in X equal to Y, I will get Y also as half. That means those two graphs of Y equal to A raised to X and line Y equal to X will meet at one point only. So their common point is nothing but half, half. So they meet at only 1 point. So basically set X has all those points which lie on the graph of Y equal to A raised to X, where A is 1 by 4, and capital Y is the set of all those points which lie on the line Y equal to X. Now, those who are not good at drawing graphs, for them I am giving that set Y will contain those points which lie on the line X equal to Y. Line X equal to Y means points 1, 1, 2, 2, 3, 3, such points when you join, the kind of line what you get, that line will pass through origin. This line you can draw set X also, and you will realize they meet at only 1 point, and that point is nothing but half, half. So X intersection Y, it is not phi, it is having one element, half, half. So X intersection Y not equal to phi should be the correct answer. Did we get X equal to Y? No, X equal to Y will never happen, because capital X is in the form of a curve and capital Y is a line. So those two are surely not equal. So the correct answer is C. Now these 3 examples were little different, not in the standard form. So I thought of taking these problems. You can still try more problems, and then when we meet in the next session, we will be starting with a new part, new topic called relations. Till then, stay tuned. Thank you.